Actually, this chapter is so long and I like it so much that I'm probably going to end up doing not just one more podcast, but maybe two more podcasts, but it doesn't matter. It's all on YouTube, so you can watch as you find time. Background: Campus is a living lab for learning in sustainability. For the purposes of this chapter, we conceptualize and apply sustainability not in terms of the Brundtland Commons 1987. I said late 1970s, I think, so it's late 1980s. Well-known definition focused on human capacities to deal with the limits to resources and reductions in pollution and waste, but rather as a process of addressing and ameliorating the wicked and ill-structured problems challenging the future of human society and nature. I like it that the word wicked problem is being used because that's exactly what these are. Consequently, we find that technological and economic fixes proposed by the Commission and its many successors to be inadequate in meeting the many and diverse challenges to sustainability. Recognizing that there is no shortage of technologies and policies that appear appropriate to solving the sustainability problems we face, why have we not been successful in deploying and implementing them? This is a critical question. We have so many technologies and understandings and efficient processes of buying them, implementing them, yet we are not anywhere near applying them for sustainability in a successful way at a large scale. According to Evans and his colleagues, living labs possess three core characteristics. They comprise a geographically or institutionally bounded space. They conduct intentional experiments that make social and or material alterations to this space, and they incorporate an explicit element of iterative learning. So there is experiential learning with active intervention. So material and social alterations are involved, experiments. The authors see living labs as offering students the opportunity to get their hands dirty with really existing problems that go beyond the classroom. Living labs have the potential to strategically frame co-production processes in two ways. First, consulting users and stakeholders allows complementary sets of projects to be strategically planned that offer holistic solutions to sustainability challenges. Second, by emphasizing the iterative process of experimenting and learning from year to year, they provide a more coherent basis for action over time. Both of these elements are valuable in a university setting, joining up the institutional response to sustainability challenges and engaging students in focused and applied projects that clearly contribute to a longer-term, bigger picture of sustainability. So on a campus, they can be seen as learning by doing experiments leading to sustainability, and then those lessons have to be transferred to the outside community, broader community. So when you implement it in a, let's say, farm site, not on campus, you cannot call that necessarily as a living lab unless you are only using it for learning and not doing some implementation. If you're actually going there to develop solutions, you can say you are using the living lab concept to develop, like a climate services lab or a natural human system interaction lab, and so on and so forth. That's my personal opinion. Systematic operationalization of the living lab idea is not necessarily easy. Beringer and Adam Bent observed that the focus of greening the campus transformation and while these efforts may coincide with an influx of seemingly related curricular innovations, the two do not necessarily intermesh. A systematic linking of academic research and teaching with facilities management and operations remains the exception. Furthermore, approaches which recognize the systemic nature of organizational change and which leverage campus sustainability via institutional drivers are yet sporadic and uncommon. So we are just beginning to think about them, experiment with them, and maybe implement them in this case. A common definition of experiential learning is learning by doing, that is, putting the student subject in a situation in which knowledge and skill must be learned and applied to address a task or solve a problem, providing a concrete experience. That's what living labs are for. They are not necessarily implementing a solution outside the lab setting. As Moon et al. Describe, in the experiential learning, the student manages their own learning rather than being told what to do. So it's learning by doing, when to do it. Not told what to do or when to do it. A relationship between student and instructor is different, with the instructor passing much of the responsibility on to the student. So you're given a goal, a problem, and you have to work on it on your own. The context for learning is different. Learning may not take place in the classroom, and there may be no textbooks or academic texts to study. Finally, the curriculum itself may not be clearly identified. The student may have to identify the knowledge they require and then acquire it themselves, reflecting on the learning as they go along. But of course, there are ways to evaluate the student and codify the knowledge they gained so that another student doesn't repeat the same mistakes or doesn't have to learn the same lesson all over again, right? To be sure, not everyone is enamored with the experiential learning. Perenet et al. Report that findings from research on misconceptions suggest that problem-based learning may not always lead to constructing the right knowledge. Kaczynski argues that it offers college credit for real-life experience, often at the expense of important academic work. So you could be sitting in a lab or a class in a traditional setting and actually learning new things, whereas here you're going and experiencing something firsthand which may not necessarily be new or innovative, and then you're getting credit for it at the expense of important academic work. Wow, you always have opposition to new ideas. The most valuable thing we can teach students is the ability to think through with patient focus, demanding intellectual challenges. Solving a difficult linear algebra problem, working to understand an intricate passage from Descartes, figuring out how exactly the findings of evolutionary morphology explain the current human stride. All these are examples of the sort of learning that we should be proud to provide our students, and not one of them features real-life engagement. Well, you can add theory of relativity, astrophysics, and everything including sustainability principles to this, but that's not the point really of experiential learning. Broadly speaking, experiential learning has its roots in problem-based learning, which originated in medical education and the effort to provide medical students with exposure to the complex and ill-structured, i.e. wicked health problems. Clinical cases in medicine did not lend themselves to simple or straightforward solutions, and often require social contextualization and sensitivity to circumstances that learners would encounter as practitioners. As Kilroy has put it, for effective acquisition of knowledge, learners need to be stimulated to restructure information they already know within a realistic context to gain new knowledge, and to then elaborate on the new information they have learned, for example by teaching it to peers or by discussing the material in a group setting. So this is key. You somehow transfer that knowledge, you make it into a record that stays so that others can learn from it. Our discussion is carried out and the findings are recorded in some form. Kilroy continues, participants are encouraged to use self-directed learning skills, placing emphasis on a person's ability to seek out and assimilate relevant information to tackle a problem at hand, to analyze a given clinical scenario, formulate and prioritize key learning objectives within that scenario, and then collect whatever additional information they think will be needed to address those objectives. So this is more like a research problem. Crucially, all this takes place within a group setting so that each individual member of the group contributes to the learning process at every stage. So the group setting can be very important because then you are learning team building, sharing responsibilities towards solving a problem on the ground. So that's also a separate set of learning along with all the others we discussed in terms of finding information that is missing and finding solutions and learning from that. So much of the recent literature on experiential learning content begins I didn't read it properly. Much of the recent literature on experiential learning content begins with Kolb's cycle of 4 learning modes, which equally emphasizes the action skills in addition interpersonal and action skills in addition to the more traditional informational and cognitive learning skills, as explained we will see in figure 1 here. Concrete experience: a new experience, situation or problem is encountered, or a prior one is recalled and reinterpreted, for example a first exposure to food waste on campus. Reflective observation: analysis of the new experience, situation or problem and identification of any inconsistencies between the experience and understanding. For example, what are the reasons for so much food being wasted? Abstract conceptualization: reflection gives rise to a new idea or a modification of an existing abstract concept. For example, food waste can be reduced by eliminating trays. This can be a transferable solution. Active experimentation: when you have a tray, people carry more food and they cannot properly judge how much they are going to really consume, and then they end up wasting. It also happens with large plates. So Google, I think, was the first one in offices to start putting smaller plates, and people were happier with lesser food. Active experimentation: application to the real world around to see what happens. For example, diners take less food and food waste is reduced. Okay, so here is figure 1, David Kolb's experiential learning cycle and some associated skills. It's a cycle, so you can start anywhere. Let's say you have here concrete experience, so doing and having an experience. Reflective observations, so reviewing, reflecting on the experience you had. And then abstract conceptualization, concluding and learning from the experience. It's not so different from doing an experiment in the lab, except now you are doing in the open with live subjects, being part of your experiment and observation, because unless you do active intervention of some sort, like changing the tray size, you are not including the subjects as active participants. Active experimentation, then planning and trying out what you have learned and to see how the concrete experience changes. So you have here various things to deal with: interpersonal skills, leadership, communication, collaboration, information skills, sense making, analysis, data accumulation, analysis, systems thinking, quantitative skills, problem solving, theoretization. So every time you collect data, you hypothesize, you get more data, you build a theory, and then you can test the theory, test the hypothesis, and then make it a theory. Organizational, time and project management, action, self-initiatives, and so on. Okay, so problem-based learning principles along 3 dimensions coming out of this: content dimension, cognitive dimension, and collaborative dimension. So here content dimension will be interdisciplinary, exemplary, theory, practice, relation, and critical thinking, and experiments based on critical analysis. Cognitive dimension will be problem-based, contextualized, whether it's food waste or other material waste, or it is energy waste, and so on. Action-oriented, experience-based. Collaborative dimension, you want participant-directed and team-organized problem learning, and dialogic and democratic, so that it's a group setting and you share responsibilities, you share learning, and you share the data gathering and analysis and problem solving as well. Okay, so this is about the continuum between problem and project-based learning. Maybe I should come back and do that in the next podcast. Maybe we'll have 2 more podcasts instead of just 1 more. But that's okay. We are learning new things here, especially if you want to set up a living lab. These are crucial elements to consider. So this is not just applicable to UCSC. These are broader concepts being brought into the contextualizing UCSC's particular establishment or particular experimentation setup with their living lab. Okay, so we'll come back and continue with additional points. In fact, there are many additional points to be made, so we'll definitely have 2 more podcasts, I think. Okay, see you in the next podcast.